Hi, welcome to this lesson on finance, future value annuities. Let's have a look at question 1. Norman wants to buy new fishing gear worth 7,400 Rand in a year's time. How much must he deposit at the end of each month into his savings account, which earns an interest rate of 9.5% per annum, compounded monthly? Okay, so let's get a timeline together to visualize what's actually happening in this problem. Okay, so I'll start off here at T0 and we'll see how far we go up to. Because we know we want it in a year's time and I'm compounding monthly, I'm going to have my last one being T12. So I'm going to have T1, T2, T3, all the way up to T11, T12. Okay, and now where do I start depositing? At the end of each month. So Norman will first deposit a certain amount X into the end of the first month, then he'll do it at the end of the second month, the end of the third month, all the way up to the end of the 11th month, and the end of the 12th month. Okay, we want to figure out how much Norman should be putting in, that X value each month, so that he ends up in the future with 7,400 Rand in a year's time, based off that interest rate. So here we can use the future value annuity formula, F equals X into, now it's going to be 1 plus I raised to the power n minus 1 all over I. So let's identify the key variables over here. So first of all, the future value, that's what we're after. So we don't know what that is. Well, no, actually, the future value we do know, right? We actually want 7,400 Rand. So we do know the future value. That's how much we want in a year's time. Okay, the interest rate I, because it's compounded monthly, the nominal interest rate is 0.095 over 12. And what I'm going to do is I'm going to store that value into my calculator into A, and I'll show you how you do that. Okay, because working with this number, typing it in a lot gets very messy in your calculations and you can often make mistakes. Okay, then we have our N. We know it's 1 year, so 1 year times the period of 12 months. So that's going to be 12-month period. And what we're looking for is X, the regular installments that Norman's going to make at the end of each month, so that when he does do that, at the end of the year, he will have 7,400 Rand. So what we actually are looking for here is this X variable. So I can rearrange the equation. So first I'll multiply both sides by I to get F times I. And on the right-hand side, I have 1 plus I to the power n minus 1 all times X. Okay, and because I want X, I can divide this entire term here. So therefore, X is going to be F times I, all divided by this quantity, 1 plus I to the power n minus 1. Okay, so once I know what X is equal to in terms of that formula, I can go ahead and use my calculator now. So what I'm going to do is first, I'm going to go 0.095 divided by 12 equals, and then I'm going to go shift RCL for store and into the variable A. So if I clear that and press alpha A, I can see I've got that interest rate there. So I'm going to substitute into that formula. So open in my numerator, I'm going to have 7,400 times the interest rate, which I've called A, all over 1 plus the interest rate A, close brackets, raised to the power of 12 months, minus 1 equals, and I get 590 Rand and 27 cents. So 590 Rand and 27 cents. Notice that when we do financial mathematics, try not to round off at each step. Try to do the calculation in one go, and then once you have your final solution, round off at the end. Okay, for more accuracy. So Norman will need to deposit 590 Rand and 27 cents each month with this interest rate if he wants to have 7,400 Rand in a year's time. All right, so that's how we would do this type of problem. I'll see you in the next one.